Hello everyone and welcome to the fourth session on 5-minute stats. In this session we'll be having a quick discussion about what do we mean by skewness and kurtosis in a data set. Coming to the basic question, what is skewness? Skewness refers to the distortion or asymmetry in a symmetrical bell curve or a normal curve. It can be quantified as a representation of the extent to which the distribution varies from a normal distribution. A normal distribution has a skewness of 0. To understand this, let's try to look at these three curves over here. The curve at the middle that you see is a normal curve which has a 0 skewness. So a normal curve is completely symmetrical when you divide it into two halves. For a normal curve, the mean, median, and mode lie at the same point. The second type of curve that you see is on the left side. That's a negatively skewed curve. Over here, you see that the mode has the maximum value. The median lies between mean and the mode. And then the third curve that is at the right is a positively skewed curve. For a positively skewed curve, the mean is the maximum and the median lies between mode and the mean. So how do we understand this? How do we interpret the skewness values? If the skewness is between minus zero point 0.5 and zero point 0.5, the data is said to be fairly symmetrical. And if it's between minus 1 and minus zero point 0.5, it's negatively skewed. And if the skewness is between zero point 0.5 and 1, the data is moderately skewed. Skewness of more than 1 or less than minus 1 represents that the data is highly skewed. Coming to the next descriptive, which is kurtosis. So before let's try to understand what do we mean by kurtosis. Kurtosis is a statistical measure that defines how heavily the tails of a distribution differ from the tails of a normal distribution. It identifies whether the tails of the given distribution contains the extreme values or not. So over here in the graph that you see over here, we have three curves. The first one in red is a leptokurtic curve. The second one in green is a mesokurtic curve, and the third one in blue is a platykurtic curve. So let's understand all these three. The first one that we'll be discussing would be the mesokurtic curve. A mesokurtic distribution a data that follows mesokurtic distribution has a kurtosis closer to 0. A normal deviation has 0 kurtosis. Sorry, a normal distribution has a 0 kurtosis. Coming to a leprokurtic curve. Leprokurtic distribution indicates positive or excess kurtosis. It shows heavy tails on either side indicating large outliers. Generally in finance, a leprokurtic distribution shows that investment returns may be prone to extreme returns on both the sides. So these investments are generally considered to be risky. The third type of curve that we have over here is the platykurtic curve, and it shows a negative kurtosis. It reveals that a distribution with a flat tails. A flat tail indicates smaller outliers in the distribution. In financial context, the platykurtic distribution of an investment return is desirable for investors because there is a small probability that the investment would experience extreme values. So, with these, we complete our session on descriptive statistics. In the next video, we'll be quickly seeing how to compute these descriptive statistics in Excel, R, and SPS. Thank you guys for watching this. If you have not yet watched our previous videos, you can watch it at our channel. If you like this video, please subscribe to our channel. You can also follow us on our blog website Vising Data and our Facebook page Vising Data. Thank you all for spending your time over here.